Okay, so what I'm gonna do is I'm gonna work some problems in the back of the book, some examples that you might need or that are for sure gonna be on the test, or the type of questions that are gonna be on the test. Um, One good idea is for you to look at page 261 because it gives you the key equations that we could potentially use for this next test. But I will give you those equations nonetheless during your exam. One of the things, one of the problems that we're going to work on is on page 262, and the question is going to be 615. The questions that I'm going to work on are going to be the ones that are not in the back of your textbook. Okay, all the ones that have the red letters or the red numbers are problems that are solved in the solutions in the student solutions manual, which is in the back of the book. Okay, so make sure that you try certain types of these kind of questions on your own. Make sure that they're labeled red so that you have the answer. For instance, on question 615, it says a sample of nitrogen gas expands in volume from 1.6 liters to 5.4 liters at constant temperature. Calculate the work done in joules if the gas expands A, against the vacuum, B, against a constant pressure of 0.8 atm, and C, against constant pressure at 3.7 atm. So essentially what we're doing is that gas is expanding, N2 expands from 1.6 liters to 5.4 liters. Okay, that's the first part. The temperature is constant, and they're telling you that they want you to calculate the work, which is the W. That's the question. And they want you to calculate it based on three scenarios. Scenario A, in a vacuum. I'm sorry, against the vacuum. Scenario B, which is against the constant pressure. So against a constant pressure, so a pressure that's not going to change. So where P is equal to 0.8 atm. And for letter C, against a pressure, again, constant, that means it's not going to change, at 3.7 atm. Okay, so the formula that you're going to use for this, so that's the question, that's the information provided. So we're going to start with A. For A, the equation that you're going to use for this equation, for this problem, is going to be work is equal to negative P and the change in your volume. Okay. So what is the next part that we're going to do? Now, since this is expanding, our work is, in this case, more than likely will be negative. Okay. So here what we have is, for example A, we know what our volume is, or the change in volume. The change in volume is going to be final volume minus volume initial. Okay. So here we're going to have, so your VF in this case is going to be your 5.4 liters minus your initial volume, which was 1.6 liters. As you get this, or as you subtract this, what you're going to end up with is a volume of, 3.8 liters. So for all your three scenarios, your liters is going to be 3.8 liters. So that's going to be your change in V. Now the pressure in the case of a vacuum. So remember that example A is against a vacuum. So for a vacuum scenario, we're going to assume that our pressure is going to be 0, okay? 0 atm. So therefore, when you plug it into your formula, which is W is equal to the negative, right? And how much pressure in a vacuum? It's going to be 0 atm. And you're going to multiply that by the change in temperature, right? And this is the change in temperature, which is going to be 3.8 liters. Anything times 0 is going to give you 0. So your work for question or part A of question 615 is going to be 0. For letter B or part B, what's going to happen here is now your pressure is going against the system at 0.8 atm. Okay, so then what we're here is you're going to have W, which is equal to a negative P change in V. Now here they told us that our pressure is going to be, our pressure is going to be 0.8 atm. And your volume or your change in volume we have already calculated, which is 3.8 liters. So the next thing you have to do is just plug it in. You have your negative value, your 0.8 atm, and your change in temperature, which is 3.8 liters. Then we end up with an answer of negative 307 or 30. How many sig figs here? For this one, they told us 2 sig figs, and it's 2, so we're gonna go to 310 or 3. I will say negative 308. Okay. Approximated, of course, and this is going to be liter atmosphere. Now there is a conversion that tells us that 1 liter atmosphere is equal to 101.3 joules. Okay. Now this conversion allows us, or we can use this conversion to go from liter atmosphere to joules, okay? In case you are asked to do the question in joules. Oops, I'm sorry. Here's the conversion factor that allows us to convert from liter atmospheres to joules, okay? So you can convert this by dividing, by multiplying this number times 101.3, and it'll give you the amount of joules. Okay. Scenario C is very similar to B and A. The thing that we're going to do is we're going to use W is equal to negative P change in volume. And what we notice in this case that our pressure is now 3.7 atmospheres. And all you're going to do is multiply that by your change in volume, which is the same. And thus for now, all you gotta do is multiply those two, gives you a value of liters times atmospheres. And again, if you wanna convert it, you can use this conversion factor that is up here to do so, okay? And that's how we do 615, 6.15, which is on page 262.